We have with us Mrs. Duncan's 5th grade class, and they are seeing Brain Drain, the role of fluid movement in brain tumors from Virginia Tech.
Okay, awesome. Well, welcome everybody. I hope you're excited for this outreach activity we have for you today. And so for those who don't know what the brain is basically responsible for a lot of what you're doing right now. You're seeing, talking to you, you're listening to me talking to you, and your brain is responsible for all these things. If you're moving right now, if you're swinging in a chair, if you're watching TV right now and not paying attention to this, either way, your brain is responsible for helping you do that. And so today we'll be talking about how basically a liquid moves throughout the brain.
Okay, so flow in the body is similar to how water flows out from a hose. Does anyone know what brain cancer is specifically?
And that's when cells reproduce multiple times, and it creates this mass that can harm the other healthy functions that exist in that organ type.
Does anyone know how we currently treat brain cancer?
So we have resection, which is shown there in the image on the far left with a scalpel, chemotherapy, which is in the middle, and then radiation, which is on the far right.
So just as Monet and Cora were talking earlier, we're transitioning into this kind of video game modeling of what you guys saw. So you guys saw it as like a big brain, and you saw fluid flow through the brain, kind of like what you could see, let's say, with your eyes. But this is like at a very small scale, like really, really small. So you need like a microscope to see it. And we put it into this kind of video game setup so you can understand what's going on.
Hey everyone, so yeah, Sal mentioned it's called an agent-based model, or an ABM for short. And the main reason we use agent-based models is to look at interactions between things. So for example, what do you think if you all were in a room together, what would you think would happen if everyone in the room just got up and started walking around? Yeah, so you might start running around, you might start bumping into each other. Would you start doing things to maybe not run into each other? What could you do to not run into each other? Yeah, yep, that's a good one. Serenity said you can stay far away, you can pay attention. Yep. Maybe you even start walking more slowly so that, yep, slow down, nice, friendly. Okay, so yeah, these are all different things that you could do to start to stop from bumping into each other. And we can do similar things for studying other phenomena or other things that happen, like traffic on the road. So how cars are going to move. We can look at movement of different cells in our body. We can even look at things like how the number of animals decrease or increase. And so that's what this agent-based modeling is doing. And we can, as everyone mentioned, we can kind of do this like a video game. So there are different objects. You'll see, Saab will explain in a second, but if you look on his screen, there's a bunch of these circles. Each of these objects has specific rules. So like how you would stop from bumping into each other by walking more slowly, we can put rules on the object in the game and kind of see how they react and interact.
You can see on the screen, and I played it a little bit, but there are some pink cells and then some like yellow, blue, red cells. So your yellow, blue, and red cells here are normal cells in the brain, let's say. And then the pink cells are kind of like the Play-Doh you just saw. They're the cancer cells. So as we've all been talking about through this whole meeting, is we got fluid flow going on, right? So if you can see, as I press play, there's kind of some pulsating blue right here, just moving across the screen. That's the flow that's in the brain. And if we look at all of these cancer cells, you can see they're growing and they're moving based off of what we told it to do.
When you look at the model, you see there are tons of different colors. But before you look at that, we know that the flow is coming from that top corner. Yeah, they're moving in the direction of the flow. So the flow is coming from the top corner, and they're moving with the flow. So if you imagine, it's kind of like if you were on a lazy river at a water park. When you're floating on your tube, you're going with the flow, with the direction of the water. If you really wanted to, you could kind of walk against the direction, but it would take a lot of work. So most of the cells are moving with the flow and going the same direction. We see all these different colors because as the cells are growing and making more, they're creating different populations. And each of these populations is going to respond a little bit differently to different treatments and to the flow. So that's why we have so many different treatment types, which Caleb is going to talk about next.
So using this agent-based model, we can now apply our different treatments. So the first treatment we had talked about was surgery, so actually cutting it out. So Sav's going to hit a button on the agent-based model, and you'll see a big circle show up in the middle. So that's going to correspond to cutting out the tumor. So that big circle is the region we just took out. So what do you notice when we take out the cells in that region? What do you notice? Are there still cells around? Yeah, so there's still a lot. So we cut out a lot of the cancer cells, but we still have a lot remaining. So we can apply other treatments. So the next thing Sav is going to put in is chemotherapy. And so when he pushes the button for chemotherapy, you'll notice the red coming down is the treatment. And so what happens to those cells when the treatment hits it? What do you see them doing? All those little dots. Are they increasing or are they decreasing? Yeah, right. We're getting rid of them, right? So they're decreasing, which is a good thing. And we can also use something else called the radiation. And so when Sav hits the radiation button, you'll see on your screen, it goes green, and then that kills off even more of those cells, right? But what do you notice? Do we still have cells remaining at the end? Are there still different color cells in there? Yeah, exactly. So there's still cells in there, right? So we want to look at different ways that we can use treatment in order to get rid of all the cells, right? Because that's what we're trying to do. So Jen's going to ask you a couple questions about the treatments.
All right, so if you were a doctor, and let's say this is your patient and you need to treat their brain cancer, you have these three options. You can choose more than one. You can choose one over the other. How would you treat your patient? You can put it in the chat if that feels best for you. What would you do to help your patient?
Yeah, so a lot of you said that you'd try all three, right? Because you saw that individually they might not kill off all the cells, but maybe if we use them all together, we can get rid of more of those cancer cells.
So there's pros and cons to each type of treatment that we currently have for brain cancer, but labs like ours all around the world are working toward improving these treatments and coming up with better ones.
Why do people get cancer in their brain?
Yeah, so there's a lot of reasons why someone might develop cancer in brain cancer. High risk or something that makes you more likely is when you're older, because as we age and as we get older, our cells have to keep dividing, and as they keep dividing, there's a greater chance that some of them might turn into these like bad cells. So there's just more of a probability or more of a chance that you might get cancer due to that. There's also other environmental or other outside impacts. So if you've ever heard that like smoking is bad for you, there's kind of a link between smoking and other types of cancers like lung cancer, because the smoke isn't good for your body, right? And so that can also lead to cells changing and becoming these bad cells as well.
While we're young, does that make our brain healthy since our cells are close together?
That's a good question. I think while you're younger, your cells haven't divided as much. So when you're younger, you tend to get less diseases, or you don't get sick as often, right? Because your cells might be a little bit healthier. So yeah.
And the brain make people get strokes. So actually that's partly like what we study in terms of like with the fluid kind of moving through the brain. Sometimes that fluid can get blocked in the brain, and when that fluid is blocked by something kind of standing in the way of it kind of flowing through the brain, you can sometimes get a stroke. So that's kind of how, that's actually a very good question, and sort of why fluid moving through your brain and not kind of having any sort of obstructive obstacles is really, really important for your brain to function. Good question.
With brain cancer, have you figured out any other way you can treat it without killing healthy brain cells?
That is the $1 million question. If you can answer that question, you can probably get a lot of money, and that's what we're trying to solve and figure out. There are a lot of labs, including ours, who are thinking of different ways of how to really look at sort of the normal what's going on with the normal cells, or other cells that kind of come through from other parts of the body that are trying to help, like immune cells. So immune cells are basically cells that try to basically clear sort of bad things when cancer arises or when bad cells are there. And so looking at sort of using those cells to our advantage to hopefully like stop cancer or continuing on or even originating. And there's like plenty of other things that there are a lot of cool things that people are doing, you know, across the United States and internationally to sort of solve this problem. We can sort of not have to do just those 3 methods. If smoking was not would brain cancer be a thing? So smoking is actually not necessarily linked to brain cancer. It's related to like lung cancer, which we don't study in our lab. However, in terms of brain cancer, we're still trying to figure out how people actually develop that.
So Dominic just asked a great question where he said, what about the good cells? And that's exactly what we're talking about right now. So Sav is sharing that those little dots in there that are blue and white, those are supposed to be healthy cells. So you can see that even after all of these therapies, we kill a lot of good, normal cells that we shouldn't be killing.
Thank you, Mrs. Duncan's class, and thank you, Brain Drain, for all of your time and information.